Welcome to today's Explainer. We are diving into something completely fascinating today. It's a really unique experiment that bridges the gap between absolute cutting-edge technology and pure retro gaming nostalgia. We're going to look at what happens when you take a state-of-the-art 2026 AI model, specifically Claude Fable 5, and give it the job of resurrecting those indestructible mobile gaming classics from the year 2000. It's a journey that starts off being all about artificial intelligence, but as you'll see, it actually ends with a really surprising revelation about human ingenuity. So to really understand this experiment, we have to start with a pretty compelling question. Can an AI actually perfectly rebuild a hazy, forgotten childhood memory? The author of our source material decided to set up the ultimate test for this. They remembered being a 3-year-old toddler back in 2003, constantly sneaking their dad's old Nokia 3310 just to play games for hours on end. But, because they were so incredibly young at the time, their actual memories of these games were super hazy. They obviously didn't remember how the code worked or even the exact mechanics. They really just remembered how playing the games made them feel. Well, the author came up with a name for this approach. They call this methodology design from memory. And it is a completely unconventional way to prompt an AI. Instead of handing Claude Fable 5 a bulleted list of strict technical specifications or game mechanics or, source code, the author literally just provided hazy feelings, vibes, and vague childhood recollections. I mean, imagine trying to explain the vibe of a game to a computer in 2003. Think about that contrast for a second because it's pretty striking. On one side, you have the abstract, emotional, fuzzy memories of a toddler from 2003. And on the other side, you have the harsh, binary reality of the exact hardware specs required to make a game function natively on a Nokia 3310 when it was released in September of 2000. Asking a machine to essentially translate toddler nostalgia into functional Python code is a massive leap. But against all odds, the AI completely pulled it off. The experiment resulted in 2 distinct, playable creations built in Python using Pygame. The legendary original Space Impact was reborn as an AI creation titled Void Runner, and the absolute timeless classic Snake 2 was reimagined by the AI as Neon Sprint. So the AI gave them flashy new names, sure, but the real question we need to answer is, did they actually play like the classics? Let's get into Case Study 1, Space Impact Reborn as Void Runner. Okay, so Space Impact wasn't just any game. Back in 2010, CNET hailed it as one of the greatest mobile games of all time. So Fable 5 had some incredibly big digital shoes to fill here, and yet, in just about 5 minutes, Fable 5 outputted a fully playable game that felt instantly familiar to the author. The AI correctly intuited the entire side-scrolling structure, and it surprisingly even included familiar power-ups like shot splitters and shields. But honestly, the craziest part was the boss fight patterns. The AI programmed the enemy behavior so accurately that it actually triggered this deeply forgotten childhood strategy in the author. It literally brought back the urge to hide in the corners of the screen and only fire when the boss moved into the line of sight. It just nailed it. Moving right along to Case Study 2, Snake 2. Reborn as Neon Sprint. Now for this one, the author actually held back on purpose. They provided an incredibly basic prompt, just asking for a game about collecting dots. But despite giving it almost nothing to work with, Fable 5 brilliantly drew on its own internal knowledge of Snake 2 to layer in all these advanced features without being asked. It automatically included forgiving traversal, meaning if you hit a wall, you loop to the other side instead of just instantly dying. It added pre-launch speed variables and even complex maze obstacles. It just intuitively knew exactly what made the game brilliant. Which brings us to Section 3, the text showdown, AI versus AI. See, the author didn't just test Claude Fable 5. They applied this exact same design from memory methodology to the other heavy hitters of 2026. We're talking Gemini 3.1 Pro, GPT 5.5, and even local models like QN3 Coder 30B, just to see who could actually handle abstract prompting. And honestly, it was a bit of a slaughter. Almost all of the other models really struggled to translate those vague mechanics into playable games, and they required a significant handholding. Fable 5, on the other hand, consistently one-shotted the games. It got the foundational game logic absolutely perfect on the very first attempt. And now for part 4, the twist, human genius. Right when you might think this is just a giant victory lap for AI, there's a massive twist. Seeing an AI recreate these iconic games in 5 minutes didn't actually make the author marvel at the AI. It made them realize the absolute unbelievable genius of the original human developers from the year 2000. We're talking about kilobytes here, just kilobytes. That is the tiny amount of memory those human developers actually had to work with. Today's AI models use massive, power-hungry server farms. But back in 2000, engineers were writing natively in C, trying to squeeze a highly engaging game out of the extremely limited microchips powering those old brick phones. And this gets to exactly why this whole explainer really matters. Recreating something is pretty easy once the design is already understood. Claude Fable 5 simply reconstructed a blueprint that already existed in its training data. But the true human genius was arriving at that flawless, addictive game design in the first place, completely out of thin air, using native C on hardware that gave them practically nothing to work with. There's a quote from the source material that just completely hits the nail on the head, and it perfectly summarizes the core takeaway here. The games were simple because the developers were anything but. It just instills this deep, genuine appreciation for constraint-driven game design. These developers didn't have massive memory banks. They didn't have AI assistants writing code for them. They had incredibly strict restrictions, and out of those restrictions, they built literal masterpieces that toddlers could pick up and remember for a lifetime. Which brings us to a final thought to wrap up this explainer. Look at where we are today. We have AI models that can generate entire code bases in 5 minutes. We have hardware with practically limitless memory and processing power. But as all of these historical hardware constraints just vanish into thin air, what might modern developers be losing? Does true creative genius actually require strict limitations to flourish? It's definitely something to think about the next time you pick up your smartphone. Thanks for joining me on this explainer, and keep exploring.